Okay, I hope you're able to see my screen. And
Yes, sir. It's
okay,
visible.
okay, the live stream has not started, unfortunately. Yeah, it started. Okay, I hope you're able to see my screen. And
Yes, sir. It's
okay,
visible.
okay, the live stream has not started, unfortunately. Yeah, it started. Okay, so we were discussing about exceptions. Okay, so exceptions means that a very simple example of exception would be division by 0. Okay, where you are trying to divide any number by 0, and division by 0 is not actually defined in mathematics, unfortunately, and because of that, right, it gives you an error. It will actually it cannot do that particular process if you try 1 by 0 or 100 by 0 or whatever number divided by 0, right, it will fail quickly. That's a very simple example for what you call as exception. Okay, so let me j python 3 and ipython, just a minute. Okay, so if I just type 1 by 0 on the ipython interpreter or the python interpreter, right, it is going to immediately give me an a zero division by 0 division error. Okay, so which means that yeah, so if I type 1 by 0, right, it's going to give me a 0 division error. So now what is going to happen with this kind of statement creeping in your program is that this can cause the program to crash. So the program, meaning that, say, let's say I'll show you the system monitor. So the system monitor, right, is going to kind of tell you the processes that are running on my system. Okay, so let it load so that you will be able to better appreciate what exactly is happening. Okay, the system monitor has started, and you can see that at the back, right, I have opened the uh, slides for today, that's regarding the exceptions. Okay, now I know that these exceptions, right, these slides that are shown are actually shown by a program called events. Okay, now I know that this program events, right, is loaded into the memory, computer's memory. Okay, and it is using some CPU and some memory space, and that is how this particular slide is actually shown and rendered over here. Now what will happen if I kill this process, say abruptly? I'm just trying to emulate what could happen if a process ends abruptly, right? Then the process actually, whatever is shown here, right, so the back, at the back I have the PDF viewer, and I know the PDF viewer's name is events. Okay, and you know that events, the 11 underscore exceptions.pdf is the one that I have opened at present. Now what I'm going to do is I'm just going to kill this particular process by right clicking on events in the process manager, okay, in the system monitor, and I click on kill, and the system, the process with the process ID 14978, right, will get killed if I kill it. So I am going to confirm killing the process. I killed it, and what has happened here is that the slides that were shown to you, right, is no longer visible, and this is because the process that was running to show the slides has actually crashed in between, or I have crashed it myself for a particular reason, to show it to you that this is what happens when the system, when a program crashes. So when the program crashes, right, it is removed from memory. So I have loaded this PDF file again, and you can see that now it has come back to the memory with a different ID 17205. Okay, so now what happens with this particular statement 1 divided by 0 in a particular program that we have written is, we have already seen that grade to GPA, right, So let's try to open that program, and we had tried to incorporate the grade 2 GPA. So Python 3 grade 2, yeah. So we had tried to incorporate these statements which cause errors in this grade 2 GPA program as well. Okay, I think this was I had explained it over here. So uncomment region. So if you look at the line numbers 22, 21 and 20 that I have highlighted over here, 1 divided by 0 is a 0 division error. There are other errors also, syntax errors, name error. Okay, syntax error means that this one, right, while true, if it had a colon over here, then this wouldn't have actually caused a problem, but still, you know, the indentation is problematic over here, so that would give you a syntax error. And another one is, here I have tried to print a variable which is non-existent until the call is done. Okay, now what will happen with these kind of errors is that the program that is executing will get crashed. The program that is executing will get crashed, or it will stop immediately without producing further results, or without completing the further computations that are pending. So which means that it will not complete the further pending computations, it will not produce any results if the program crashes in between. And now the program has crashed due to an exception, and we are trying to learn how we can handle exception in Python programming language. And in any programming language that you may come across, you will see that exceptions are general in almost every programming language that you can imagine of. Take C programming language, take C++, okay, take assembly programming language. Anywhere, if there is a 1 divided by 0, that is not a defined mathematical operation, and that would actually result in an error or an exception, and that could cause the program to crash or the program to stop immediately without producing any further results. So we have to have some logic or some code or mechanism inbuilt in our code to handle the exceptions, so that even when an exception happens, right, the program should not ideally stop. The program should still continue generating results, and the program should also continue further computations than getting stopped or killed all of a sudden. Okay, so that is what we are trying to do with the handling the exceptions. So we have seen that there is a try catch block, right? So in Python it's called a try except block. So whatever is the statements that we are not sure, I'm in the class, whatever be the statements that we are not sure whether it would cause the program to crash, okay, we can put it in the try block. So meaning that here in this example we have num is equal to int of a, okay. So a is what? A is equal to input of prompt. Prompt is what? Enter a number and q to quit, which means that input, we know that in Python input is a function which will take the input from the standard keyboard, the standard input keyboard, and it will store it into the variable. So we know that input function always returns a string, okay. So a contains a string, but the string characters can be numeral characters 1 2 3 4 5 6 7 8 9 10, I mean 10 or 0, or it could be any number, or it could also be a string which is not a number. Now if it is a string which is not a number, num is equal to int of a. So we are going to convert the string a into integer. Now it can be, this particular statement can execute only if the value of a is actually a number value that is stored in there, okay, as in the string. It can be a string, but it should be only numerals in the a. In that case you can do an int of a. Say for example a is equal to x, okay, and I do an int of a, okay, num is equal to int of a, it will give me a value error. Okay. On the other hand, if a was 1 2 3 and I try num is equal to int of a and I try what is there in num, I can see that num has the 1 2 3. So, earlier a had 1 2 3 in string and num is equal to int of a worked because a contained just 1 2 3, that is the numerals. Okay. So, which means that there could be different reasons for which it can fail, and now in this example we have a it could fail because the user has entered a character which is not a numeral or a character which is other than q. Okay. So, here if it contains even q or any other string, only string characters and not numerals, in that case this particular statement would actually cause to fail. Okay. It will fail, it will raise a value error, and now that is where the except block comes in. The except block is going to execute immediately when the try block raises an error, or whenever the try block raises an exception, the except block immediately starts so as to handle the exception, and that is what we mean by handling the exceptions. So, the exceptions can be either not named or it can be named. So, in this particular example, in the slide number 9 that we are seeing, we have not given any named exception, meaning that whatever be the exception, okay, over here in num is equal to int of a or in print num, whatever be the exception that happens here, it will any exception, it will be handled by this logic in the except block. But then there can be certain cases where you do not want to handle a certain kind of exception, or you want to handle a certain kind of exception in some other way. How can you do that? And that is where you can actually handle the exceptions by the exception name. Okay. So, you can handle the exceptions a little better by using the specific exceptions. In this example, they have used except value error. So, earlier, right, in the slide number 9, it would get invoked for any exception that is raised in the try block, but in this exception value error, if the try block raises a value error, only in that case will this exception be raised, or will this exception be handled. So, the try block has to raise a value error, and if it is a value error, this exception block will handle it. If any other exception is raised, say zero division error or name error or any other exception is raised, it will not be handled by this value error block. Okay. So, that is an example for handling an exception with a specific exception. So, in the previous example, in the slide number 9, we have seen the exceptions were handled by the exception handler handled any exception that was actually raised by the try block. But in this example, if the try block raises value error, then this block will get executed. Similarly, so let us say if you have a program like this where prompt is enter a number and while true try x is equal to int of input prompt. Now, this try block is within a within a while loop, okay, and this will break if the exception does not get called, or if the try block does not raise an exception, then it will break. When does it not raise an exception? When it has entered only numerals in the input,
Yes.
and we are able to convert it into integer, correct?
Yes.
Yes. So, which means that this will keep executing indefinitely until the user enters a proper number. If the user enters only string which can't be converted into a proper number, until then it will keep executing, and when the user enters a proper number, the exception will not get executed, and since the exception did not get executed, or since there were no exceptions, this first line will be executed successfully, and then the second line break will be executed, and the break will break you out of a loop. Is the if else construct a loop?
Yes, sir.
Who said yes? If else. So my question was, can I use, say, if I had, if instead of this being a while true, right, if I had it to be a if block, can I use a break statement here? No, because the break statement can be used only to break out of a loop. Loop means an iteration. So it has to be either a for loop or a while that has to be there for you to use this break. Okay, so this is with exceptions. Now, if you have multiple exceptions, right, we can actually handle it this way. So you can actually have a try block, okay, where it can raise more than one exception. Okay, it's possible. So for example, in this one, right, in the slide number 12 that we are seeing here, while true, try is equal to, try data is equal to input. So data will get some value from the input. So let's try that. Data is equal to input. Okay, and what kind of input does it need? I don't know anything about what kind of input it needs. So I'm just going to give it some value like A, B, okay, 1, 2, 3, enter. So what does that data have? Data has the value 1, 2, 3, but it is of type what? String. It's of type string. Okay. So data is equal to input. This line number 7 worked fine. It did not produce any exception. Now what I am going to do is x is equal to int of data, okay, dot split, okay, with comma, and take the second position. Okay. So I have data, and now can someone tell me what kind of exception is it going to raise? So is it going to raise an exception because it could not convert it into an integer, or is it going to raise an exception because it could not find split, or is it going to raise an exception because it could not find the second element in the list?
And the basic can be, it cannot be converted into int.
It cannot be converted into int. That's incorrect, because I can do that. What is going to happen is data dot split. So here data is 1, 2, 3. Now data dot split with comma, it cannot split it. So it means it is going to let's try that. Let's take another IPython terminal. Okay, and data is equal to 1, 2, 3, okay, in string, and next what we want to do is data dot split, right, split with comma. What is going to happen? What will it return? It will return the same element without splitting into a list. If I used 2 here, right, it would have split it into 1 and 3. If I had data is equal to, let's say 1, 2, 3, comma 1, in that case data dot split with comma would work, and it will give me 1, 2, 3, comma 1 as a list, 1, 2, 3 as the first element of the list and 1 as the second element of the list. Okay. Now going back, now we know that data is 123 over here, and data dot split is going to return a list with one element, but the index value 1 is looking for the second element in the list. So it is going to give you an index error. Okay, it give you an index error, correct, right? So I was asking you whether it is going to give you an index error or a value error. Now in this particular example, right, I am going to do one more one slight change. I am going to execute data is equal to input once again, and I am going to give a comma 1. Okay. Oh, that is going to work. This will work. This will have x as 1. Okay, I am going to run this program again and 1 comma a, and this time it is going to produce a value error, because I have 1 comma a in the data, and when I split it with comma, I will have 1 as the first element of the list and a as the second element of the list. So data dot split with comma, taking the second element, is going to take a, and it is going to try and convert it into an integer, which is going to raise a value error. Do you guys follow what I have tried to explain over here? So
Yes, sir.
okay, so I started from the slide number 9, from where we had stopped the class last time. So in the slide number 9, we are handling any exception that is raised in the try block. In the slide number 10, we are handling only the value error in the except block. So which means that if the int of a fails, only then it will work. And this was another example to show you how we will proceed with the exceptions, and how we will wait until the user enters a proper number. Okay. And here we are actually trying to learn, in the slide number 12, we are trying to learn how we can actually have a try block which can produce multiple exceptions, and the exceptions are handled by different handlers. So which means that in the try block you have data is equal to input, x is equal to int of data dot split comma of 1. Okay. So which means that it is looking for a number value, correct, a number value like a comma 1 to be entered by the user. Okay. So this program will work only if the user enters a comma in the string and enters some number, some valid number on the second position after the comma. Okay. So the program will still work if I have something like a comma 1 comma a comma b. Would it work? So I have right now data is equal to a1 ab. Okay. Now I am just going to do x is equal to int of data dot split comma 1. Would it work or not, is my question. Students?
I think yes, sir, because it only
Yes, sir.
specifies the index number.
Okay, so some students have given me the answer yes. Is there someone who says no? Okay, so 2 students I believe gave me an answer yes, and yes, it will work, because what is going to happen here is we have a1 ab as a string which is separated by commas, and data dot split with comma is going to give you a list of 4 elements, a, then the second element 1, then the third element a, then the fourth element b, and data dot split with comma first element, I'm sorry, the second element, because of 1, right, index 1 is looking for the second element, is going to be numeral 1, and that will work, correct. If I had data is equal to, let's say data is equal to input a comma 1 2 3 4 comma b comma c comma 1 2, it will still work, and the value of x would be 1 2 3 4, correct.
Yes.
Okay. So which means that here in this try block it could raise 2 kind of errors. One is an index error and another is a value error. And we have written 2 exception handlers here. One exception handler is for the index error and another exception handler is for the value error. Okay. So the exception for the handler for the index error prints some some statement, and for the value error it prints something which is relevant for the value error. So invalid input, try again, or input at least 2 values. Okay. So this is how you can actually catch multiple exceptions in a single try block, from a single try block. Okay. You can have more exceptions there if you want. So you can also do it this way, where you can have one single except block handling 2 different errors. Okay. So here, right, we have an index error and another one is value error. Index error is handled by the first exception handler, where it prints input at least 2 values. The value error is handled by the exception handler, invalid input, try again. Correct, right? But if you can actually have single statement, which will handle only index error and value error. So unlike the previous thing where we learned in the slide number 9, so right now in slide number 12 we have 2 exceptions handled separately. In slide number 9 we have seen that we have a try block which can raise an exception, and we have an except block which will accept or which will work for any kind of exception. Okay, but here in slide number 13 we have an except block which will get invoked for value error and index error. So which means that it will not get invoked for zero division by zero division error. Okay, so let's assume that int of data dot split of comma of 1, right? This try block, if it raises a zero division error, this try block, if it by any chance raises a zero division error, this except block is not going to handle it, because this except block is written to handle only value error and index error. So whenever the try block is going to generate either a value error or an index error, it is going to print invalid input. Okay. So this is how you can catch multiple exceptions with one single handler, or you can have multiple handlers for the different exceptions. Is that clear, students?
Yes.
Okay. Now this is another thing where you can have an else statement for the exception, which means that we want to, let's say, kind of know whether the exception handler executed or not. Okay. So if the exception handler doesn't execute, then you can say all is well, break. Okay. So let's try this particular program. So okay, what I'm going to do is I'm taking the Emacs editor, and while true. Okay, let me save this as exception example 2.py. Okay, let's also take a look at what is exception example 1.py. Okay, so exception example 1 gave where we handled a value error. Okay, and in the exception example 2 we have a else block after the try and except part. So data is equal to input, x is equal to int data dot split, okay, and except value error, except value error, and next one is index error. Okay, for both of these exceptions we will just print invalid input, try again. Okay, so this is what we will print. Otherwise, if everything is fine, if the exception did not have to execute, we will print I would say exception was not raised this time, because it's a indefinite loop, right? Because it's a while loop, while true, and then finally you have a break. So let's try and see whether it is going to run. So percentage run minus I exception example 2. Okay. So I have to enter some proper value in the second index, or that means that after the comma I have to enter a proper number. That is what is expected in this program. So I am just trying to enter 1 comma a. It says invalid input, try again. Then I am trying 1 comma b. It says invalid input, try again. I am trying a comma b comma c. It says invalid input, try again. Now I am trying a comma 1 comma c, and this time it will not say invalid input, try again, but it will say exception was not raised this time. Okay. Do you guys follow what has happened here?
Yes, sir.
That's pretty simple, right? And it's pretty simple for you to understand as well. So we know that if we can have an else part also for if the exception was not raised. Okay. If I do not have a break here, right, it will go back and continue the loop and the try block again. Okay. Or else I can give a break here also. But if I give a break here, right, if I give a break here, then this else block will not get executed. So in practice, right, whenever we are writing program, we will never use blanket except clauses, which means that we will never use some exception handler which can handle every exception. We will not do that. So whatever we have done in slide number 9, right, should not be done. This is a blanket exception, meaning that whatever exception the try block is going to raise is going to be handled by the exception block, which is not right. So in practice, that is in real world, and when you write proper try exception blocks, etc., you will never use blanket except clauses. Always catch specific exceptions. How do you know what kind of exception is it going to produce? Because you know that if I type 1 divided by 0, right, it will give me a 0 division error. So which means that I can include 0 division error here. Okay, and since I am in the Python mode for Emacs, and it knows that this is a exception name, it has actually properly formatted within a different color. Okay. Next, you can raise an error message, okay, for a particular exception. So raise value error your error message. So it will print your error message if the error is okay. So instead of using the else, right, instead of using the try except else, there is also another thing called try except and finally. Okay, try, true, try, x is equal to int of input prompt, break, except value error, print invalid number, try again, and instead of else we have an finally all good. So instead of else, right, let's try whether it is going to do anything. Okay, so I have removed the break statement from here, if you have noticed. So earlier, right, I had a break statement along with the else statement. Now I have replaced the else with finally, and I am removing the break statement also. Let's try and see what happens. So I am trying to run percentage run minus I exception example 2. It's going to ask me to enter an input. So 1 comma a. Oh, by the way, it gave me finally exception was not raised this time. That is incorrect. Okay, so it should be just all good, but it is asking me for the second time, right? So it has to be 1 comma 1 comma a, and invalid input. Okay, so you need to have a break there if you want to break out of the loop. Okay, let's try that once again. 1 comma a,
Sir, the
oh,
break was after data dot split.
no, wait, so see, remember this, I am just trying to show you the difference between the previous one and the new one. So earlier we had else and the break inside the else part. So this break will work if there are no exceptions raised. Okay, so we can, let's try giving the finally here. Okay, so percentage run minus I exception example 2 1 comma a, it was raised, exception was raised this time. So this is not correct. Okay, this means the finally statements are executed after exception is handled or raised slash not raised. That's how I would write it for the time being. So let's try that once again. 1 comma a, it says the finally statements are executed after exception raised slash not raised. So we do not know whether the exception was raised or it was not raised. Okay, but we know from this particular statement the exception was raised. So let's now try 1 comma 1. Okay, this now says that the exception, this finally statement, right, executed whether the exception was raised or not raised. Okay, but the invalid input try again was not printed the second time because it did not raise the exception. So the finally statement, right, will be executed after the exception handlers are to be executed, if any. Okay, so that is what you should understand from this particular thing. So you have a try and finally. Okay, and the finally, right, it is not like the else part. So in the else part, right, we had try except else. The else would be executed only if the exception is not called. But in the try finally blocks, the finally block will always run at the end of the try block, whether the exception was raised or not. Is it clear?
Yes.
Any doubts regarding that particular topic? So if else, okay, try except else and try except finally. So these are the two things that we have come across right now. And another thing that we came across was the specific name for the exceptions. So exception handling for the specific exceptions rather than the blanket exception handler. So we will never use the blanket exception clauses. We have to always use the specific exceptions. We can actually raise an exception with a custom error message if required. And then we have come across the try except finally blocks. Okay. So here we have def f of x, try y is equal to int of x, return y. Okay. Except value error, print x, finally print finally. So f of 1 is going to print, it's going to just return 1. So let's try and see what happens. So this is the third exception example, right? B xw exception example 3.py def f of x, try y is equal to int of x, right, and return y. Okay, so this, there is a possibility that it can give you a value error. So except value error, print x, and finally print finally. Okay, so this is what we have in our program. So let's try this particular statement. Okay, so when we run this particular exception example 3, right, this function is going to be defined in our namespace, in our workspace. So percentage run minus okay, and exception example 3. Okay, so now we have f of x. So f of what was the first example that they have given? F of 1, it gives us finally 1, and because it returns 1, and if I give a, it will give you a and finally, because it raised the value error and then it printed finally. But because there is no while loop or anything over here, right, it will just try it only once and it will gracefully proceed without causing the program to crash. Okay, so that is what you need to understand. So this is exceptions, try and finally. So in summary, we have learned catching exceptions with try and except blocks, catching multiple exceptions, and clean up with finally. So finally means that you can also have some other statements if you want to delete some previous variables that you had created, or some things that you wanted to do after this try and except part, you can actually execute it in the finally statement. Okay, and you can raise your own exceptions as well. Okay, so you can raise value error, your exception, your error message. So I can say raise value error, there is some error. Okay, so it will get printed like this. So we have covered very basic topics regarding exceptions and whatever we have covered so far. Okay, now let's go to the next set of slides, which is set of 12. Okay, which is where we have the practice sections for the files and exceptions. It was not compiled, I believe. Just a second. So that's 1 of 1 that is given over here, right? So I'm just trying to compile it once again, and let's see whether it is going to change. Yes, it has changed to 1 of 15. So you know, because there is some references that has to be made, etc. It works only with 2-pass compilation. Okay, you will come across something like 2-pass compilation, etc. in some context in computer science. Okay, where you have something like symbol table and creation of symbol table, forward references, etc. I am just giving you a hint. Oh, by the way, you are in ECE, so would you come across that? You might, because I don't know all the electronic syllabus. Anyway, so let's go with the practice exercise for the files and exceptions. So we have an exercise for reading from a file. So the question is, you have to create a function called largest, which will take a single argument. The argument passed will be an opened file object. Read the data in the file. Assume that the data is separated by spaces and are all numbers. Find the maximum value in the file. So that is the question, right? And it's mentioned, do not use load text. So let's try to create the sample data file. Sample data file.
Sir,
Yes.
I want to ask that. So, what is better to write a program with simple words or with try and accept? Because if you are knowing how to write a program, then there should be no use of writing try and accept.
No, there are possibilities where, you know, during the runtime where the user enters data, where you are reading from a stream. Let's assume. Okay, let's assume. Who asked me this question?
Abhishek, sir.
Okay, Abhishek. So Abhishek is asking the question whether we need to always write programs with try and except, or it is required when you are not very confident in writing programs. Is that correct, Abhishek?
Yes.
Okay, so that's like you know, that's like that's a very confused question, first of all, because if you're not confident, you cannot use try except blocks also, right? Because you do not know whether an exception is going to happen or not. Okay, you cannot foresee all the possibilities where the program could crash. Okay, so which means that a person who will write try and except blocks will also be somewhat proficient with the kind of work that he or she is doing, and knows that these are the kind of exceptions that could arise, like for example name error, value error, zero division error, multiple other exceptions. Okay, we have seen few exceptions. Okay, now why should we write programs with exceptions, or should we write programs with exceptions all the time? No, we need not write programs with exceptions all the time. But why should we write it if at all we have to write, is the next question. So we have to write it because so as to avoid unwanted errors from crashing your program. Say for example, in the examples that we have seen with exceptions so far in today's class, all of it required the user to enter some data in some specific format, correct? And if the
Yes.
user made an error, then the exception handler was called. So if the user made an error, humans are prone to make mistakes. Humans do make mistakes. We are not like computers where we can continuously and without getting tired do repeated calculations. No, we cannot do that. We do get tired. We cannot do repeated calculations. We do make mistakes. Computers do not make mistakes. Okay, so humans can make an data entry error, and what if your program is going to fail because of this data entry error? So in that case, it is a good practice to have a try except block, where you think the user could probably make an error in entering the data. So that is one place. Another place, let us assume that you have written a program that is going to read some inputs or some data from some devices or some sensors that are remote, okay, that are somewhere else. So which means that this sensor or this system that is not near your program is going to send you some data over the internet or over the codes. So once you get this data, right, you have to process it, but during the transmission sorry, during the transmission of the data between the sensor and your program, it is possible that the data could get corrupted. What would happen if the data gets corrupted? The program that you have written would fail. And imagine a situation where you are actually working on something called Internet of Things. How many of you know what is IoT? Okay, I think somebody has raised their hand probably. Yeah, Badraksh Bhargava kind of knows what is IoT, and Prajwal Venkatesh Sindegar also kind of knows what IoT is. So essentially what you can think of IoT is that you have multiple devices that are spread around the the campus or the country, and you want to actually collect data from those devices in a phased manner, in a continuous manner, okay, so as to calculate some predictions, okay, or to make some predictions. Let's say for example weather forecasting, okay, so which means that I need to have some sensors probably to sense the geological that's the earth's movements. I need some sensors to uh, sense the temperature rise and temperatures throughout the day. I need some sensor to measure the precipitation, meaning that the water that is actually falling down on the earth due to rain. Okay, so those are few sensors. And what if I have some other use cases where I want to continuously monitor my body vitals. Let's say I have a wristband or something that is going to keep on recording certain data. Okay, so which means that there are multiple sensors around the world or around me which I am interested in, because that data can be used for making predictions. I can say that there is a chance of rain tomorrow based on all the data I have collected. I can say that there is a chance of earthquake. I can say that there is a chance of tsunami, right? So all of these things, how are they done? They are done by sensors and collecting the data and continuously monitoring it. Okay, now in our example that I am trying to give you, let's assume that we have such sensors called the Internet of Things, IoT sensors, okay, for different aspects, and we are computer science people or electronics people, and we want everything to be automated. Okay, we want everything to be automated. Now we know that each sensor is going to give us some kind of data. One is going to give us string data, another one is going to give us a complex number, another one is going to give a list of numbers, another one is going to give a list of complex numbers, or anything. It could be anything. Okay, so those are the assumptions with which we will write programs to receive the data from these sensors and to process it. So the program that we have written would be working continuously and would be getting the data from these sensors continuously and performing the computations continuously so as to produce predictions. Now, is it possible that the sensors could malfunction due to some reason, or the data that is sent by the sensor to the program is not received properly by the program because there was a communication error? It is all possible, right?
Yes.
Yes. I mean, I'll give you another example, very simple example. Let's assume that all of you subscribe to newspaper, the normal newspaper where the newspaper wala hai na सुबह आपका घर पे न्यूज़पेपर छोड़ देगा. So the newspaper guy is going to throw the newspaper into your house and you get the newspaper and you're going to read it. That's a very simple most thing. Now imagine there was some rain and the ink that was used by the newspaper printing press was not very nice, that it just some of the words got erased during the rain. Okay, now when you get the newspaper, right, you will see that some of the words are missing. How will you make out or figure out what is actually the news that you have in the newspaper? You won't be able to, because you have some of the characters that is lost due to the rain because of the bad quality of the ink that was used by the newspaper guys. So that is a very simple example where it is always possible that any part of your program can crash. Now Abhishek asked me a very good question. Now I worked in a company, okay, after my PhD I worked in a company called Gojek. So what was this company? Gojek. Okay, so Gojek is a super app with transport, payments, food delivery. Like you can say that it is an application which has multiple uh, tools in that, meaning that you can actually book a courier, you can send a courier, you can book a two-wheeler taxi, you can book a four-wheeler taxi. Okay, you can also book a truck to move your ship or shift your house from one place to the other place. Okay, you can, there are multiple things, you can order food from Gojek. Okay, you can order movie tickets from Gojek, you can make payments with Gojek. All of these things are possible. Now I worked on a very crucial module of Gojek that was called the serviceability, meaning that given a latitude, longitude, I need to figure out which of the Gojek services are available in that location. Okay, so that is the thing, which means that any program or any, as in I told you that there are multiple things, right? For example, go ride, go car, and all of those things. And I think, let me see whether that's just for the transport and logistics. Let's see whether they have more information. Unfortunately, I'm not able to find it because I left Gojek some time back. Anyway, let me see. Check. Can we get some more details from here? Yes. So you can see that there are now more products. You can also order a massage through Gojek. Okay. You can also order medicines through Gojek. You can shop through Gojek. So all of these things are possible. Now, what is going to happen is that with the serviceability API that we were writing, all these Gojek services would use the serviceability API, meaning that if the program crashes in between, could be for any reason, because the computer ran out of space of memory, or another or another API which serviceability could be using failed. Okay, so there could be n reasons. Okay, Akash saying that we have another class. Oh, is it which class, Akash? Okay.
SSDs.
Okay.
Solid state.
Solid state devices. Okay. So essentially, I think we are done with this particular thing. We have to you guys take this as an example. This as a question for you to solve, and try to solve it by yourself, this particular question. And with the question that Abhishek asked, no, it is always a good practice to write programs which are resilient, which are which can come back from failure, which can continue computation even if it fails. Okay, if you write a program that is just going to fail without for any reason which you may not be knowing, right? It would be very difficult for you to write a server side software or a backend tool. Okay, so which means that if any crash happens, the program will stop, and this is very costly, because for a software tool that has to work 24/7, if the software tool crashes, right, and it does not revive or it does not come back to process again, it will be very costly for the company or the people who are involved. So yes, you need to write the thing. Now Bhadraksh has written the program for the particular question, so I'll just go through it. Others can leave. Okay, we are done with the class. I'll just go through this and you can join for the SST class, please. File is equal to open file name def largest content. Okay, file dot read r strip l strip a list of numbers sorted list map int content dot split map int was true. So I'm just going to copy this and I will try it on my system. Thank you, Bhadraksh. Okay, and Akash, can you also please do me a favor? Akash has left. Again, Abhishek, Aditya, Afrit, Anshika, Bhadraksh. Okay, Akash and Rishik left. Thank you, guys. We'll meet tomorrow. Abhishek, is that question answered?
Yes, sir.
Okay,
I
are you able to
understood, sir.
understand that
Yes,
you
sir. I
have to
understood
write
why
the
to use try and accept, sir.
yes, because you cannot afford a program to crash all of a sudden and it doesn't come back, it won't, that particular process will not be existing on the server, right? That's the problem. All right, anyway, thank you guys, bye, see you.
Thank you, sir.